today we're going to do some more factoring, trinomials specifically. But I've got a chart up here because when you factor, the type of polynomial you're dealing with establishes how you're going to go about factoring it. But I want to highlight real quick, and maybe you can do some sort of way to make this one step more important than everything else, because it's the first step, and it's year after year the step that people forget to do when they're factoring. Anytime it says factor completely or even factor, they imply the completely. Step one is to find the greatest common factor and take it out. Alright? That means, we've done this before back around lesson, I don't know, maybe 32 or something like that, it's been a while. But if I have 7x squared plus 3x, right? X is in both terms. That's what it means to factor out the greatest common factor. That is step one of every factoring problem. And every problem that you're going to get today is going to have a greatest common factor in it. Alright, so when you see the problems in your homework tonight, if there's a little 71 in parentheses underneath it, I bet there's a common factor. Okay, if it says 69, it probably doesn't have a common factor because that's the first time we look at the trinomials. Once you've taken the common factor out, you're left with this piece here, and that's either going to be a binomial, a trinomial, or more than 3-term polynomial. Okay? With binomials, there's only two things to consider. First thing is difference of squares. Okay? That's something we're going to investigate here shortly. Probably in the next 4 or 5 lessons, or maybe even sooner than that. Haven't looked far enough ahead in the book yet to know, but it happens very shortly after this lesson. When it comes time to factor difference of squares, I'll explain what they are, how to identify them, and how to factor them. Those are pretty easy. It's just a special form. And then the other thing, sum or difference of cubes. That's something we don't handle this year. We do that in Algebra II, and we'll revisit the topic in geotrig, and we'll put it to use in calculus. For trinomials, so far the factoring chart's the only type of factoring we've seen for trinomials. There's also a perfect square trinomial. Alright, that's a special type of trinomial we're going to be visiting by the end of the year, but not any time in the near future. And factoring chart is what we've already done, and eventually with trinomials you're going to get to a guess and check technique. That's the technique I use for factoring trinomials every single time. I've done so many of them I can pretty much look at them and tell you what the factor form is. I can do a quick check to make sure they're right. The guess is write down the answer, the check is verify that's the right answer. And when it is, you move on to the next problem. And with 3 or more terms, there's going to be a factor by grouping. That's going to be a special type of factoring. I want to say less than 101, if I remember right, is when factor by grouping comes in. So that'll be this year also. But regardless of all this stuff down in this chart, none of that happens before a greatest common factor check. And if any greatest common factor is there, you need to pull it out first. All right, so, example 1. And again, on your papers it says example 2. Misprint on my part. It should be 1 and 2 on top, 3 and 4 on the bottom.
Can you go back really quick? I wasn't done writing everything down.
When I'm done with this example, I'll shoot back to that page real quick, Parker.
I was almost done now.
What?
I was almost
You'll
done.
be fine. Okay. 71.1. Factor 4bx cubed minus 4bx squared minus 80bx. So it says factor. And again, our first step of factoring is look for a greatest common factor. Okay. Again, we visited this topic first time like lesson 31, 32, somewhere in there. Okay. Hopefully you guys can look at these things and identify a common factor pretty easily. The greatest common factor is the largest number
But the smallest.
and the smallest power of a common letter. So largest number that divides into all the numbers and the smallest power of a common letter. So let's take a look at the pieces here. 4, 4, 80. Looking just at the numbers. What's the largest number that divides 4, 4, and 80?
4.
4. We find a common letter such as B. B, B, B. What's the smallest power of B?
B.
B to the first. Okay, then we got X, X, X. What's the smallest power of X?
X first.
X to the first. That's how you find a common factor. The biggest number that divides all the numbers and then any common letter, its smallest power. Once you've written down the greatest common factor, then inside the parentheses we're going to write the leftovers. The leftovers are each piece divided by the common factor. So let's start with 4bx cubed. 4 divided by 4 is 1, b divided by b is 1, x cubed divided by x is x squared. Only write down the 1 if nothing else is there. Once the x squared is there, you don't have to write down the 1. Next one. Minus 4 divided by 4 is minus 1, b divided by b is 1, x squared divided by x is x. So minus 1x, better known as minus x. Negative 80 divided by 4 is negative 20. b divided by b cancels, x divided by x cancels. So altogether, after I take out my common factor of 4bx, the remaining polynomial expression, x squared minus x minus 20 is left over. That was step 1 of factoring. Greatest common factor, find it, take it out, factor correctly. Step 2 is to look at the remaining polynomial. In other words, here.
Not even highlighting anymore.
Alright. Okay, I got it all. Alright. The remaining polynomial, whatever's in that parentheses, it is either going to be a binomial or a trinomial or more than 3-term polynomial. It's a trinomial. So the only type of factor we know how to do at this point is the factoring chart. The factoring chart will be the same one it was in lesson 69. We're looking for factors of a negative 20 whose sum is negative 1. Right? The numbers are important, not the letters, when you're factoring. So the constant, whatever this number is, including the sign, is what we're looking for, the numbers that multiply to make. And then whatever number's in front of x, which is negative 1 understood, is the sum. In order to make a negative product, I need to have opposite sign numbers. In order for the sum to be negative, I need the bigger number to be negative. So if I start at positive 1 and negative 20, that makes the negative 20 product, negative 19 sum, not the right pair. Positive 2 and negative 10 makes negative 8. We skip 3 because 3 doesn't go into 20. Positive 4 and negative 5 makes negative 1. So again, you do a systematic approach to this. You do each pair, and then you don't skip any, you find the right pair. All right? If you happen to see right off the top of your head 4 and negative 5, by all means go ahead. You don't have to go through these two to find that one. But I'm just saying that if you're having trouble finding it, going through systematically like that really helps. So, positive 4 and negative 5 are the correct breakdown for this part. X plus 4, x minus 5. Then the 4bx that we took out is still part of the factored form. And we're done once we factor the trinomial completely.
Oh, so now we're just factoring every single thing that is.
Yeah, you want to factor everything completely always. So take the common factor out first. That's part of the answer. But then the remaining polynomial should factor it again after that. If it's not factorable, if this happened to be prime, let's say this said minus 7x. Minus 7 didn't show up on our list, right? We got all our factors. Then we'd stop here. That'd be the factored form.